beginning to rain.
Hello, you've tuned into the program Fresh Bread, a program dedicated to discussing the things of the kingdom of God. Today's topic is a multiple-part series on creation and evolution. This course is designed for those who may not have a science background. However, be forewarned, I will be dealing with quite a bit of science. But as I go, I'll explain the terms and concepts so as to be understandable to all those that might be listening with a non-science background. On a 1 to a 10 scale, 10 being the highest, my interest in this subject has always remained about a 2, but once I learned that there's a boatload of people out there, mostly unbelievers, who value it around a 10, I decided to do some research in the subject to help dispel misinformation and inform those who may need more information. Of the top 10 reasons unbelievers dismiss the Bible as untrue, 6 of them revolve around the first few chapters of Genesis. I'll be discussing these chapters in depth during this session. My background is molecular biology, microbiology, vaccine development, and biochemistry. I was a researcher for about 8 years at the University of Montana, where I got my PhD in this biochemistry. Chemistry, investigating the mechanisms of mutation in human, yeast, and bacterial genes. To do this course right, one really should be expert in 5 fields: physics, geology, theology, philosophy, and evolutionary biology. I've had some physics on the college level, including some relativity and nuclear physics, a few college-level geology courses, extensive self-research in theology. I'm 2 courses short of a bachelor's degree in philosophy, and I have quite a bit of expertise in genetics at the molecular level. So this doesn't make me an expert on any of the 5 fields, but I'd like for you to know where I'm coming from and weigh it in your minds accordingly. Whenever you listen to someone discussing this subject, you should always get a handle on their background. There are a lot of well-meaning people out there that speak what they know not of, unfortunately, even from the pulpit. As I go along, I will make comments as to the depth of my knowledge on any given subject. Some of the physics concepts I discuss are frankly over my head, so I'm basically repeating what I hear experts in the field say about it. Which brings me to the next subject. In the past, I considered myself a so-called young earther, that is, a Christian who believes the earth and the universe are only about 10,000 years old. Many years ago now, I came across Dr. Hugh Ross, a former radio astronomer turned Christian evangelist, who convinced me that modern science and the Bible are indeed compatible, and that the earth and universe are on the order of 4.5 and 13.7 billion years old, respectively. His seminal book, Fingerprint of God, is the basis of this course. I will be referring to it frequently. His website is called reasons.org. He has a molecular biologist and a Christian philosopher on staff also. He has a weekly podcast and a weekday online devotional. His website is a huge database of information. He and his staff speak frequently across the globe and in many major universities across the U.S. If you are of the persuasion that the earth and universe are young, like I once did, give this course a chance. At the very least, see why folks like me believe the way they do. Fortunately, whether you believe in a young or old earth, the way to the Father is still through the Son, and believers can be on either side of this issue and still be born again, going to heaven, believers. It's a huge mistake, I believe, to make this a divisive issue in the church. The Scripture says, let everyone be fully persuaded in what he believes, but we don't need to let differing beliefs divide us to the point that we can't fellowship one with another over it. Eschatology, the study of end times events as they pertain to the Bible, and of course I will be teaching here in the future, is also a divisive topic within the church. There's no need to break fellowship with someone over these issues. They're minor compared to the basic message of salvation. As I'm speaking, figures will appear on the screen. These figures, as well as an audio version of this lesson, are available on my website, brightstarministries.org. As I go through the course, I will be referring to these figures. All right, so before I launch, I should lay out a few definitions that will be helpful. Cosmology is the study of the cosmos, or the physical universe, how it came to be. Creationism is the theological account of origin. All major religions, including Christianity, have an origin account. I will only discuss briefly other religions and center mainly on the Christian biblical account. I need to explain exponential notation. If you remember way back in your high school math, log base 10. For example, 10 to the second, the number 10 with a little 2 written up to the right top hand corner means 10 times 10, or 100. 10 to the 23rd means 1 with 23 zeros after it. When you multiply exponential numbers, you simply add the exponents. So, for example, 10 to the second times 10 to the third equals 10 to the fifth, or 1 with 5 zeros after it. So this kind of notation is helpful when dealing with very large or very small numbers, and I'll be using exponential notation in this lesson. On the negative side, 10 to the minus 2 equals 0.01. Another way of saying this would be 1/100th, or 1 with the decimal place moved to the left 2 places. So 10 to the minus 23rd power means 1 with 22 zeros in front of it. This is a very small number. So you got it? If not, hopefully as we go through some of the data and figures, it will become more understandable. All right, let's begin. Everyone has basic assumptions they make. These should be laid out in front so everyone knows where they're coming from. I will make 2 assumptions in this course. The first is that the Bible is true. I'm not going to spend any time trying to prove this. I've done that in another session. There are many books written on this subject that you could read on your own. One of them is in the suggested reading list by Josh McDowell. I will flash that suggested reading list at the very end of this course. I will be referring to many scriptures in this course. I assume they are all true. The second assumption is that we can understand these scriptures. There's a whole discipline in philosophy called epistemology that delves into the most important topic of knowledge. How do we know anything? Unfortunately, in this course, we don't have the time to explore it. I'd also like to point out in this course that I will only be dealing with things we observe in nature. I won't be dealing with much about speculative things that have not been observed, but still might be believed by some. The basic premise of this course goes something like this. Science observes nature. Scientists make theory and create experiments based on these theories to explain what we observe. It is undeniable that Western culture has seen great gains in this discipline, especially in the last 400 years. This does not mean science gets everything right. But, on the other hand, their track record is pretty good. What we observe in nature and how we interpret what we observe can, however, lead us astray at times. Scripture is unfortunately subject to the same flaw. What we read and how we interpret what we read can lead us into different directions. If God created both nature and inspired the Bible to be written, then these 2 disciplines must cohere. If they don't, something must be wrong with our interpretation of nature, our interpretation of Scripture, or both. They cannot disagree. So this is big right here. Get this point. The whole course stems on this syllogism. The Bible has some science in it, but not much. It was never intended to be a science book. Science does not really address the question of why or who, so much as what. Putting these together, science can be a sort of 67th book of the Bible. There's 66 books in the Bible. It can help us explain some things that are left out of the Bible, and the Bible can help us explain the who and the why that science doesn't address. Together, we get a better picture, I believe, of what's going on than if we just use one or the other exclusively. As this course unfolds, I hope to convince you that these two disciplines are indeed compatible with one another. My premise is not to meld these on purpose or try to force them to cohere, but that they do so without that much trouble on their own. Again, the same author, God, made them both, so one would expect them to dovetail nicely one with another. Now, it's possible that science can violently contradict theology. Theology is the study of God and the Bible and includes many interpretations. For example, St. Augustine, an eminent church father of the 3rd century, maintained that the earth was flat. He based his interpretation on Isaiah 40:22, which says, "It is he that sits upon the circle of the earth, and the inhabitants thereof are as grasshoppers, that stretches out the heavens as a curtain, and spreads them out as a tent to dwell in." End quote. The word curtain connotes 2 dimensions, flat, but the word tent connotes 3 dimensions, sphere. He focused on the first and ignored the second. Science can also misinterpret data. For example, the disease of malaria. It had been known for some time that the disease always seemed to occur in swampy areas that tended to stink. Malaria means bad air in Latin. For centuries, people believed that it was the bad air around swamps which caused the disease. It turns out that this is merely a coincidence. There's no direct cause. It happens that the mosquito, which carries the microscopic parasite, likes to breed around swampy areas. And it was actually a parasite in the mosquito that caused the disease. Bible and facts of nature must concur because the same person created both. If there is a contradiction between the two, there must be a problem in interpretation or perspective. The Bible declares God created the universe. That's Genesis 1:1, Hebrews 11:3. God is responsible for the words of the Bible. That's 2 Peter 1:21 and 22. Therefore, no contradiction between the facts of nature and the facts of the Bible is possible. Otherwise, God is a liar or inconsistent. Yet God states in the Word or the Bible that one of the reasons He created earth and nature was to testify of His existence, to proclaim the gospel. Any apparent contradiction must stem then from human misinterpretation. So figure 1 now shows the scriptural support of nature being sort of an evangelistic tool for God. Man makes mistakes. We increase our probability of getting it right by using both natural and supernatural revelation. But in doing this, we get ourselves in a lot of controversy and emotion. We can avoid this by not just looking at Genesis 1 and 2 for the creation story, but to the whole Bible. All right, so much for the intro. Let's move on now into the first large section of this course, which is cosmology. The reason I deal with this topic up front is because of all the topics discussed, this one has the most data and is the most definitive. I'm putting my best foot forward. So, cosmology, again, is the study of the universe, its structure, origin, development. Just as an aside, cosmogony is a similar subject, but is more philosophical in nature than physical. I won't be dealing with that here. Looking at the history of the subject, Figure 2 gives a graphic of man's perspective of the size of the universe over time. At the beginning, a recorded history and Western man thought the universe extended no more than what stars could be seen on a starry night, sort of at the outer reaches of the Earth's atmosphere. The early Greeks, who lived around 500 BC, did some experimenting to discover that it was larger than that. Figure 3 shows a few of these experiments. They use simple geometry to give a fairly accurate estimate of the distance from the Earth to the Sun. In southern Egypt, they dug a deep well, and notice on certain days of the year, at solstice, there was no shadow in the well because the sun was directly overhead. But at the same time, in northern Egypt, there was a 7-degree shadow from vertical. Accounting for the distance between the two locations, about 500 miles, they calculated the distance to the sun. They also looked at first and third quarter moons to measure the same distance but by a different means. The number they arrived at wasn't as accurate, but they figured the sun was 20 times further away from us than the moon. They concluded that the sun, being a half degree of an arc unit, was much larger than the moon and the earth, which was accurate. Based merely on its large size, they surmised the sun was the center of the universe. This is not true, but this knowledge did expand man's thinking of how large the universe is. They looked at a lunar eclipse, you see this in figure 4, and measured the curvature of the shadow to calculate the relative size of the earth and moon and how far away the moon was from the earth. They were only off by 1 degree. They also noticed the stars exhibited no parallax. Parallax can be demonstrated by the following. Close one eye and hold one finger out in front of you at full arm's length. Now close one eye and open the other. What you'll notice is your finger moves. That's called parallax. If you do the same thing when looking at something way off in the distance, in the horizon, you won't see a shift because the objects on the horizon are too far away relative to the distance between your two eyes. Since they saw no shift in star position when the Earth had rotated halfway around its orbit, they concluded rightly that stars must be very far away. We can see parallax with closer stars with our modern telescopes, but the shift is very slight and requires very precise equipment and measurements to detect this movement in stars much further away. Obviously, the Greeks didn't have this advantage. So back to figure 2, the graphic shows a jump in perceived size of the universe around this time. Well, along came the great philosopher Plato, who lived around 400 BC. He was not an engineer or astronomer or scientist. To his thinking, such folks were not in the same league as philosophers. He rather looked down on such thinking. He was more given to pure reason as the way to truth. Since philosophy was the greatest discipline and only humans could engage in it, the earth where they live must be the center of the universe, he reasoned. This is known as the geocentric universe model. Since Plato was so highly and hugely successful and influential, this notion stuck and trumped earlier thinkers. Now our idea of how big the universe is shrunk a bit, as is shown in figure 2. And for the next 1500 years or so, the universe wasn't very big in the thinking of man. The early church was heavily influenced by Plato and Aristotle, one of Plato's most eminent students. The geocentric universe became dogma. Well, moving forward several hundred years to Augustine, 400 AD, he came up with 5 arguments for the existence of God to defend various false doctrines that were floating around at the time. These arguments are still germane today, I believe. The first is the cosmological argument, which states that the effect of the universe's existence must have a suitable cause. This codifies the law of cause and effect. Every effect must have a cause. God is the first cause. So figure 5 lists these arguments. The second argument is called the ontological argument. Ontology means the nature of being or reality. It states that we have a God consciousness. This implies a God who imprinted such a consciousness on humans. Even atheists think about God. Where did they get the concept? This is a very powerful argument, in my opinion. Psalms 139 speaks of this, and Also, Ecclesiastes 3:11 speaks of the sense of eternity, which is in everyone's heart. A missionary named Dan Richardson wrote a book on this subject named Eternity in Our Hearts by Regal Books. He had been involved with several indigenous ancient people groups over the years and noted that they all, even though they were not Christians, had this consciousness, corporately and individually. The third argument is the moral argument. This is the idea that the law of God, summarized by the Ten Commandments, is written in our hearts, regardless of geography, culture, or history. Romans 2:14 and 50 corroborates. This must have been implanted in our conscience by a higher being. Paul used all three of these arguments with the Greeks in Acts 17:24 through 31. Figure 6 lists scriptures which support these three arguments. The fourth argument is the rational argument, which states that the operation of the universe works according to order and a natural law. This implies a mind behind it. There is a modern-day movement along these lines called intelligent design. If there's a mind, there must be a personality, because it has never been observed in nature the presence of an intelligence without personality. If there is a personality, there must be a divine being. Roger Bacon, a great thinker of the early Renaissance, took this premise and formed the now famous scientific method from it. His ideas revolutionized society and science. The effects of this are felt even today. The last argument is called the teleological argument, which states that the design of the universe implies purpose or direction behind it. Well, moving on to the 12th century with a man named Maimonides, a famous Jewish philosopher, he subdivided the cosmological arguments into 5, making 9 arguments total. Thomas Aquinas of the 13th century, the great Catholic champion of the church, plagiarized these for his writings in his day. Just parenthetically, back then plagiarism was commonplace and not thought to be wrong. They are shown on the bottom half of figure 5. The first says that motion presupposes an original mover. This presaged Newton's law of motion. The second said an infinite series of causes. It is impossible to conceive, therefore there must be a first cause, i.e. God. And even if it is an infinite series, something must have caused it. We have no evidence in life of an uncaused effect. For example, if you come upon the scene of an accident, the immediate response is, what happened? No one thinks the accident occurred spontaneously without cause. There is an exception taken to this in subatomic world, which we'll treat on later in this course. The third argument states the conditional demands that which is absolute, or a non-contingent being. One of the 3 primary names of God is Jehovah, which means the self-existent one. The fourth argument says where there are degrees of perfection, there must therefore ultimately be absolute perfection, which is God. Plato popularized this idea over a millennium earlier, but did not incorporate the idea of a creator God, separate and distinct from the created universe as the Bible teaches. The fifth argument states there is design and government in the world, hence there is ultimately a first designer and a first governor. Objects and events have the appearance of being controlled by an overruling design, as an arrow being shot by an archer. Up to this time, Western society was more or less homogeneously Christian. Beginning with the Renaissance, people began seriously questioning the existence of God and the validity of Christianity. Immanuel Kant, 1724 to 1804, was a mathematician, astronomer, and philosopher. He tore down these arguments one by one, though he never attacked them all 9 as a whole. His arguments were circular, but back in the 18th century, Germany, certain things could be accepted without proof. Circular reasoning, or begging the question, is the case where the proposition to be proved is assumed implicitly or explicitly in the premise. Kant's unstated fundamental axiom or premise is God's existence is not provable. From this type of thinking, we derive our modern ideas of agnosticism. Therefore, he suggested 1. Man's knowledge is limited to that which he can obtain through the 5 senses. 2. A cause can never be proved from its effect. 3. No existence beyond the humanly experienced dimensions can be proved. 4. No absolute can ever be established to exist. 5. Miracles are illusory and cannot be proven to be true. The conclusion, he said, God's existence lies beyond the reach of man's knowledge. One of the problems with philosophy is that it tends to center up on the mind and sidelines the heart of man. This is a huge mistake. The scripture says the natural mind is enmity against God and not subject to his laws. That's Romans 8:7. It also says we perceive God with our hearts, Ephesians 2:8, and that eternity is written in our hearts, Ecclesiastes 3:11. So trying to apprehend God with the mind is like trying to smell with the eyes. It's the wrong organ to use. This is not to say that Christians must throw out their minds in order to believe. No. The scripture says we are to worship God with all our minds as well as our hearts. It does say, however, we must renew our mind and let it be transformed or changed supernaturally by his Spirit within us. Initially, it is necessary to go with the heart despite the misgivings of the head. Later on, after the born-again experience, the mind can be changed to think like God thinks via supernatural revelation. The objection to this is that we must be somehow brainwashed, and that's bad. But this assumes the natural world is good. It's not. God has told us in Scripture that the world is presently cursed and that sin caused this to happen. Sin was not God's idea. Really, heaven is normal. The Garden of Eden was normal. We will discuss these things in more detail later. Kant's ideas had the following implications in cosmology, combining them with Newton's laws of motion. His ideas implied the development of the universe is strictly mechanistic, or it worked by cause and effect of physical matter and forces. 2, the universe has no beginning in time. 3, the universe is infinite in extent. 4, time and space are strictly relative. 5, everything about and in the universe can be explained by the laws of physics. Ergo, what do we need God to explain anything? These ideas are tabulated in Figure 7. Kant introduced differential calculus. He demonstrated that with one set of data points, one could predict acceleration or deceleration of objects forward and backward in time. Thus, the history of the universe could be explained and the future predicted. To his credit, he hedged by saying we don't have accurate data points yet to do this. And in 1775, he published a theoretical book on the development of the universe. He said the universe must be infinite because nothing less would fit an infinite God. So he still believed in God in an abstract sort of way. His book, Critique of Pure Reason, written 30 years later, uses philosophy to prove the universe is infinite. Therefore, we don't need God. He laid the philosophical basis for Darwinian evolution. Given enough time and the materials, he implied, I'll give you German philosophers, or humans, but nothing less than an infinite universe will do. As we'll see shortly, this is not the case. Interestingly, Kant bought the moral argument for the existence of God. But his and our awareness of God is necessarily subjective. That is, whatever you think about God is valid. This led us to the ideas of modern-day behaviorism, existentialism, fascism, Freudianism, hedonism, humanism, libertarianism, Marxist communism, pragmatism, relativism, and neo-Darwinism. Well, the next several decades after Kant, actually saw support of his ideas. Looking at figure 8, in 1830s, William Herschel was a famous English astronomer. In his day, large telescopes were being built that enabled us to look further and further out into the universe. So back to figure 2, we see an increase in the perceived size of the universe all the way up to the infinite, thanks to Kant. What we'll be seeing very soon now after this is a decrease from the infinite to our present day assessment of the size of the universe, which is 13.7 billion light years. But more on that later. So Herschel started counting stars in specific areas of the sky. He noticed an asymmetry of density. That is, stars were clustered in groups which were encompassed by areas of empty space. He noticed that our sun, which is a star, is embedded in a giant lens-shaped system of stars. Thus, our probing of the universe was revealing more and more stars that could not be seen without the aid of a telescope. This supported Kant's idea of an infinite universe with an infinite number of stars, solar systems, galaxies, galaxy clusters, large clusters, superclusters, etc. Before telescopes, people thought there were only about 6,000 stars, which is the number of visible stars in the sky at night. The universe is huge. Newton's laws of motion seem to explain the movement of every and all objects, both in the heavens and on earth. This lent credence to the notion of infinite time because these equations predicted with such accuracy bodies in motion. It must be the case that one could project backwards and forwards in time infinitely. Newton, who was himself a believer of the Bible, came up with the idea of an infinite universe. Later, philosophers and scientists, including Kant, picked up on this idea. As a side note, even though someone is an expert in one field does not mean he or she is an expert in all fields. We see this in modern-day popular books written by physicists and astronomers. They may be great physicists, but that doesn't make them great philosophers. The same is true philosophers. So be aware of their science. The planet Neptune was predicted to exist before it was ever observed, based on the movement of other planets nearby. Astronomers found it the very same night they predicted it on paper. This gave further credence to an infinite universe and Kant's cosmology. If you look at figure 8. A phenomenon called Olbers' paradox gave further support to Kant's cosmology. The paradox was first proposed by Digges in 1576. He noted that at night the sky is dark. But how can this be if the universe is infinite? If infinite, the sky should be bright at night for the following reason. If you were to count all the stars at a given distance x from the Earth, there is given off a certain amount of light from them. Call this the first shell or sphere of light. Now double that distance out from the Earth and count the number of stars in the second shell, and add this with the number in the first cell. Since the three-dimensional volume of sphere increases by the power of 3 relative to the diameter of the sphere, that should now be x to the third more stars and more light than the first shell. Since the intensity of the light falls off by the square of the distance, the net effect is twice the amount of light with each new sphere. Now do the same calculation for 4 times the distance, then 8 times, etc., etc. Do this an infinite number of times, and you should get an infinite amount of light. But this is not what we observe. Therefore, the universe is not infinite in the extent the paradox implies. This is called Olbers' paradox. You can get a better explanation of this on Wikipedia if you care to. Ed Harley in 1715 popularized Digges' argument. Jussieu in 1744 and Olbers in 1823 came up with the answer. Dust absorbs light, therefore the universe really is infinite. Robert Trumpler in 1930 found evidence for this dust and found that it did indeed absorb light, sometimes by a factor of 10. Thus, for 150 years, Kant's ideas went unchallenged. In Figure 9, we progress to the future with Einstein just around the corner, and we experience some problems. In 1879, Joseph Stephans published results of experiments on black body radiation and thermodynamics, which seemed to contradict the so-called resolution of Olber's paradox. Black body radiation is a theoretical concept which has no real counterpart in nature, but serves as a useful ideal. If any type of radiation impinges upon an object, that object will absorb some of that energy into itself and then, in turn, radiate it back out into space again, releasing what energy it absorbed earlier, like the sidewalk on a hot day will absorb sunlight and heat during the day and then radiate it back off at night in the form of heat. Well, a black body radiator is an object that absorbs radiation completely and radiates it back completely without any loss either way. Theoretically, the amount radiated back out must exactly equal the amount that is absorbed. Black bodies are idealistic, but without much mathematical adjustments, the same model fits any body or real object in space. Thus, dust, the so-called answer to Olber's paradox, must radiate back the same amount of energy it absorbed. Again, we should see no darkness during nighttime hours, yet we do. How do we understand this? Hermann Bondi pointed this out in 1960. Therefore, the universe can't be infinite, he argued. How simple. Yet science overlooked this concept for decades. At this time, I think I would like to introduce the electromagnetic spectrum. This is in Figure 10 on your screen. So I have to lay out a little more science on you that's necessary before I proceed. Electromagnetic energy is a fancy name for light. It comes in many flavors, or more specifically wavelengths. Visible light, the wavelengths the human eye sees, is only a very small part of a much greater whole. If we use a meter on our unit of length, visible light is measured in nanometers, which means billionths of a meter. That's extremely small. We can't see that small. Moving to the right on the scale from the visible, we find ultraviolet light. This is also known as UV or black light. It looks a rich purple into our eyes. It's the wavelength of light that is harmful to be in when tanning on the beach. Continuing to the right, after this is X-ray, which of course is used in X-ray machines. And then finally gamma radiation on the extreme right. And this is a very harmful form of radiation. It can cause cancer and even death, as in an atomic blast. Moving to the left of the visible light spectrum, we have the infrared light. This is heat. The heat lamps you see over fast foods are this kind of light. Next to that, going to the left further, are microwaves, like in our microwave oven. And then continuing to radio waves, which we send out music over the air to receivers at home. Our sun and all stars give off all these wavelengths of light in various degrees and intensities. So this is important background information for future reference. All right, enough of that hardcore science stuff. Back to Kant. Another problem with Kant's cosmology involved the gravitational potential paradox. Newton had the tools to do this, as did other astronomers since his time, but never bothered to do this rather simple calculation. In 1871, Johann Zollner stated that if Newton's equations are correct, and there is an infinite universe, then it should be impossible to determine the force of gravity at any point in the universe. Yet it is possible. His paper was ignored. In 1896, Seeliger and Neumann verified Zollner's findings. Obviously, we can calculate the gravity of any system. Therefore, something's wrong with our assumption of an infinite universe. They said there must be some repulsive counterbalancing force to account for this discrepancy. It's an interesting idea, but at this time there was no observational data to support it. Let me make another aside at this point. Science in the last 400 years has been published publicly in specialized journals devoted to very specific subcategories. For instance, Mutation Research is a journal devoted to research that specifically deals with mutations in genes and organisms. These journals are peer-reviewed. This is a very important concept. This means that other scientists within that field have to look over your paper that you wish to publish to check for conceptual and other errors before it can be published. This process tends to weed out bad research or erroneous ideas from getting into the collective literature. This system isn't foolproof, but it's a lot better than Reader's Digest. Incidentally, it costs the scientists about $500 these days to publish in a journal. It's a lot of work to get published. And once it's published, though, like law, it becomes precedent, and you and others can quote it with authority to bolster your point. When you try to get published, it is often rejected at first for revision or some other errors. This makes science vigorous and robust. All right, enough of that. Let's go on. Now we enter so-called non-classical physics. At the end of the 19th century, physicists were saying they were done. There's nothing left to explain. All the work has been done, so they thought. Maxwell had described electromagnetism. Newton had described gravity. All that had to be done was push to the next decimal point of accuracy to verify what we already knew. Enter Michelson and Morley, a duo who won the Nobel Prize in 1907 and did an experiment in 1887 at Case Western University that shook the foundations of physics. This too, incidentally, can be read about in more detail on Wikipedia. It was rather a simple experiment. They wanted to measure the speed of light relative to the motion of the ether in which they thought the Earth and all other heavenly bodies passed through in their respective motions. They anticipated a Doppler effect, but found none. The Doppler effect in sound is the phenomenon of hearing a train or a car coming at you with a certain higher pitch than when it passes you by. Sound waves travel relatively slowly, on the order of about 700 miles an hour. The car or train's speed contributes to the speed of the sound waves it produces, let's say from a horn blast. This increases the frequency of the sound, which makes it sound higher in pitch than it would if the train were at rest. Then as it passes you by, that same speed takes away from the speed of sound of that horn blast, and this decreases the frequency of sound, and it sounds lower in pitch to the ear as it zooms by. Well, light can actually do this too. We'll discuss this more in detail later. Sound needs air molecules to work. In space, there is virtually no air molecule, so consequently there's no sound in space, contrary to the popular Hollywood depictions. Ether, quote, was the name given to the medium through which people thought light had to travel, analogously to air and sound waves. Well, depending on where the observer observes, light waves should compress or decompress like sound waves do in air through this ether. Well, they found no such compression. They tried their experiment at different times of the year and all possible angles. The results were always the same. For the next 20 years, astronomers tried to use classical physics to explain their results without success. The inescapable conclusion was that the speed of light is constant to all observers. Well, along came Einstein. He was non-academic, he was audacious, no compunction, nothing to lose. He had a can't fire me kind of attitude. This actually gave him liberty that others in his field didn't enjoy. But he was also a genius. In 1905, he published his theory of special relativity. The top half of figure 11 shows how the length, velocity, and mass of an object, and even time itself, could change depending on how fast the object is going. The equation is simple. V stands for velocity. C is the speed of light, which is about 186,000 miles per second. If you do the math, you'll find that the so-called dilation factor is essentially 1 when you're going as fast as a car or a jet. But when you start approaching the speed of light, funny things start happening. Time slows down. Things get heavier. Many experiments have been done over the years to verify the veracity of this theory. It works. To mention one, when John Glenn, the first man to orbit the Earth 7 times, they put an atomic clock on board his spacecraft, which orbited about 18,000 miles an hour. The clock was accurate to 12 decimal points. They calculated that he was actually 1/10,000th of a second younger when he returned than had he stayed on Earth for the same length of time. Time had dilated for him when he would travel at that high rate of speed. Approaching the speed of light, it would appear to us looking at him that it would take 100 years for him to lift a fork to his mouth. Now, it actually didn't take genius to figure this out back then. If Einstein hadn't come up with his special relativity theory, there would have been others who would have. His real genius came with the publication of his general theory of relativity, which included acceleration, which is the change of speed relative to time. As you accelerate onto the freeway, for example, your speed changes over time. Once you reach highway speed, you stop accelerating, even though you're still traveling at a certain speed. The equations shown in the lower half of figure 11 are said to be the most beautiful equations ever written and discovered. I'm not going to try to explain them in detail. I couldn't if I wanted to, but I'd like to point out some startling points. Let's focus on equation 3 first. The numbers and letters to the left of the equal signs is the acceleration term. On the other side of the equal sign are 4 physical constants. C is the velocity of light. The capital P is the pressure of the universe. The lowercase p, as actually rho, is the density of the universe. And G is gravity. All 4 of these are positive values, but notice there's a negative sign in front of the whole mess. This is key. A negative sign implies the universe is decelerating, like when you take your foot off the accelerator and your speed starts decreasing. The density P over time is decreasing. So putting these two things together, the universe is expanding and decelerating at the same time. This is the description of an explosion, like a hand grenade going off and the fragments expanding out from the point of the explosion in all directions, eventually slowing down and simultaneously expanding as the shrapnel shreds out into space. This is the origin of the idea of the Big Bang. It implies a creator. This is huge. Actually, Einstein, although a Jew, was very uncomfortable with this. He wanted a static universe, one without beginning or end, kind of like Kant's infinite universe. An explosion implied a beginning and an end. This is the principle of cause and effect. We see the effect, we infer a cause, i.e. God. This was a direct challenge to the Newtonian Kantian infinite universe model, and direct proof for the existence of God. Einstein was not very audacious asserting this. So to retain a static universe and eliminate origin, he proposed a fudge factor, a fifth force of physics. The 4 known forces of the universe are electromagnetism, strong and weak nuclear force, and gravity. Looking at equation 4 in figure 10, If you compare it with equation 3, you'll notice another ditty at the end. That's his fudge factor. It's a repulsive force that would cause two masses to oppose each other. When close, the force is weak. When far away, it's strong. Kind of like anti-gravity. If this were true, he could have his static infinite universe. Well, this theory was tested a few years later in Pasadena, California, at the 100-inch Mount Wilson telescope. Edwin Hubble looked for general movements of galaxy. By 1949, he had made 40 measurements. His results? The further away a galaxy is from us, the faster it moves. This could only be true if the universe was expanding. To get a handle on this, if you take a balloon and make a few marks on it, 2 marks close together and another mark further away, and then blow it up, you'll find that the 2 closer marks are closer to one another relative to the 3rd mark that's further away. So Hubble's data was in perfect agreement with Einstein's original equation 3 without the fudge factor. Einstein was shown the results, and on the spot he admitted he was wrong. He referred to this later as his greatest blunder of his career. Thereafter, he never used it. He then asserted that the universe must have a beginning and a beginner. He espoused a Spinoza-type God, intelligent, who creates but is not personal, and does not care for the human race. This is in contrast to the God of the Bible, who is transcendent but personal and intimately concerned, involved with humans. Rabbis in Einstein's time said this is inconsistent. How can God be creative and intelligent and not personal? This is a contradiction. There has never been observed in real time of a being who was intelligent but impersonal. Einstein said, if that's true, why is there so much evil and suffering in the world? For 25 years, they said nothing in response. Only God knows, they said. This is a shame. I'll be dealing with evil and suffering later on in this course. It's explainable. The Bible is the only holy book that addresses this question and gives answers to this paradox. The first 3 and last 3 chapters of the Bible pretty much says it all. The first 3 chapters treat on the origin of the universe, earth, and sin. The last 3 treat on the resolution of all things back to the state better than the original, before the sin messed things up. Most physicists, having looked at the facts, come up with a Spinoza-type God and not the biblical God because of the evil and suffering issue. Einstein admitted God existed in the face of Kant and unbelieving peers, to his credit. Whether he was born again, I don't know, one hoped. Einstein's peers admitted that his fudge factor didn't work, but castigated him for giving up too soon. They still wanted a static universe. To this day, there are still a few holdouts, but most astronomers believe now in the Big Bang origin of the universe. In the last decade or so, some remarkable discoveries have been made that might resurrect Einstein's fudge factor, though it is unlikely to upset the Big Bang scenario, though it will probably refine it. Astronomers simulating the normal gravitational forces of a galaxy notice that it quickly flies apart. There simply is not enough gravity, given the amount of mass in a galaxy, to hold it together. In the 1930s, an astronomer named Fritz Zwicky proposed dark matter as an additional source of gravitational force necessary to hold the visible mass of the universe together. Well, now we have discovered this stuff called dark matter indirectly. It does not behave like regular matter. We can't see it, but we can see its effects of gravity on things we do see. About 80% of matter in the universe is dark, astronomers, cosmologists say, while only ordinary matter is about 20%. So dark matter is the glue that really holds galaxies together. Even more bizarre than this is stuff called dark energy. Like dark matter, we don't really know what it is. It's a repulsive force, kind of like anti-gravity, and makes the universe actually accelerate in its expansion rate. It accounts for approximately 74% of the mass energy of the universe. Time will tell how this affects our understanding of the origin and fate of the universe. If the universe were allowed to run its course in time, the universe will either end up as a cold, dark bunch of ash, because all the usable energy will have been consumed, and entropy maximized. Entropy is the measure of disorder and the amount of unusable energy. Or the very dimensions of time and space will fall apart and the universe will literally rip to shreds. Bizarre, huh? We don't need to worry about this all in our time. It's billions and billions of years in the future, and more than likely the Lord will have created the new heavens and earth by then. But existentially, it's huge. All right, moving on. A Belgian priest named Georges Lemaitre, an associate of the famous Sir Arthur Eddington, schooled in astronomy, took Hubble's measurements and calculated a date of the creation event. He came up with 2 billion years ago. He made the disclaimer in his paper that his date is approximate since the data points were poor. In our day, they would be incredibly poor by a factor of 10. They thought at the time that the age of the Earth was about 3.5 billion years old. So how could the Earth be almost twice as old as the universe itself? So he said, no, the universe isn't 2 billion years old, it's longer. He proposed, through Einstein's math and fudge factor, a near static intermediary time. So figure 12 is a cartoon of this. During this time, galaxies would form, which would then bring about an expansion phase again, in which we are now a part of. We can make this intermediate period arbitrarily long to accommodate the age of the Earth. Though this doesn't work because galaxies must form before Earth can form. Eddington, who was an atheist, proposed this intermediary phase time interval to be infinite. He referred to God as anti-chance. This model was accepted for 60 years. Only relatively recently have we come up with data to refute this model. In 1974, Iranian-Armenian astronomer Vahe Petrosian, in a now classic paper, stated, if the universe has any pause period, it can't be longer than a certain diameter. At redshift distance of 2.5, quasars and galaxies would peter out. At that time, no one had seen any objects over a redshift of 2.5. So parenthetically, redshift is a jargon term referring to the Doppler effect of light as the object emitting light is moving away from the observer, causing a shift to the red or the longer wavelengths. In the 1980s, objects with redshifts of 4.1 were being observed. This is the edge of the universe. At 4.0, the object is calculated to be about 15 billion light years away. This proved there was no pause state. Joseph Silk and Ken Brecher later showed that if there were a static time more than 1 trillion years, galaxies would form, but there would also be a rapid collapse of the universe. This isn't happening, therefore any stationary phase must be less than 1 trillion years. This is very small for neo-Darwinists. I will discuss this in more detail later. In Ross's book, Fingerprint of Time, there's mention of other evidences against so-called hesitation model of the universe. That's on pages 95 and 96 of his book. And figure 13 on your screen summarizes these. All right, I think I'm going to stop here at this point. I will continue next time, continuing with cosmology. God bless you. See you next time. And remember, the whole earth is full of His glory. Blessed. Bye-bye.
It's beginning to rain.